Welcome everyone to the June novice meeting. My name is Chris Morisette. I'm the novice chairperson for the Houston Astronomical Society, and I wanted to welcome you to tonight's meeting. What we will do, if you have questions during the course of the meeting, put those in the chat. And Steve Goldberg has graciously volunteered to moderate the Q&A, and he'll look through that and glean out the questions. And also, while I'm presenting, if you would go on mute, that would be great. It would just avoid any feedback in the presentation. Okay, great. Well, listen, I'm really excited about tonight's meeting called Celestial Wonders Down Under, Exploring the Night Skies of Australia. Um, a little story, about 3 years ago, I went to New Zealand and I took my camera and night lens and my iPhone and I kind of messed around and took some pictures of the night sky in front of the mountains, this, that, and the other, and it was great fun. And then I got home and I started going through all my pictures and I thought, I've got some things here that would be instructional. And if I'd have put a little bit of thought into my journey down there and how I took pictures and pictures and subjects that I took pictures of, I could have really had something here that would have had instructional value for the Houston Astronomical Society. So fast forward 3 years, I'm planning a trip to Australia, and I've got my moment to redeem myself from the Australia trip. So what you're going to see tonight are the results of that astronomy expedition. So the agenda tonight will be as follows. I'm going to talk about my objectives for the astronomy expedition. I'll then talk a little bit about the equipment that I used, talk about the observing locations that I went to, and then we'll pivot somewhat and we'll talk about getting the measure of the southern skies. And we'll do that kind of in the same vein that we do the quarterly night sky presentations that I do each at the beginning of each season. We'll kind of replicate that technique and talk about the southern skies. Then we'll go ahead and have a sky tour of some really amazing objects from down there. And we'll talk about, the image, and we'll also talk about some of the history and physical attributes of about 10 or 11 objects that I've got. I'll give you some final thoughts about my trip and about the content that was put together, and then we'll conclude with Q&A that Steve will moderate, and after that we'll have just a quick set of announcements on SIG meetings and the general meeting for tomorrow. Okay, so expedition objectives, and I'm talking specifically here about my astronomy exploits because I did have other things on my trip agenda. But for the astronomy piece of this, what I really wanted to do first and foremost was learn about the skies of the Southern Hemisphere firsthand. So if you're a regular to the meetings, the quarterly meetings in particular, you'll know that I go through and talk about signposts and various objects that are available for us to use to find our way around the night sky and then ultimately to view. Um, and then also lately we've been trying to do novice labs to really put some meat on the bones, so to speak. You get the classroom lecture. The novice labs are really to get out there and try it for real. Kind of the same thing here. I kind of had, for lack of a better term, kind of an extended novice lab down in Australia. And so I wanted to learn firsthand about the night skies and learn more about the night skies than what I experienced 3 years ago. I also wanted to image DSOs that we typically don't view here at home. And there are some really wonderful deep sky objects down there. And I know that at least one of these we can see in our own backyard out at the dark site, but most of these are out of range for us because of the latitude that we sit at. So I put together a nice list of targets, And then after that, really thought about the astrophotography kit that I was going to need to have in order to take images. And then also did some observing location scouting on the internet. And then when I got down there, I talked to the locals to kind of confirm I was on the right track. At the end of the day, what I really wanted to do is create some really nice instructional material. When I first started out in astronomy here at HAS, you'd hear bits and pieces about the southern skies, but nothing that, for lack of a better term, that I thought was really methodical that kind of put it into context for us. So my hope is that this presentation tonight will serve, and the recording will serve as a way for new members to get acquainted with the southern night skies. And then finally, really just wanted to have some fun. It's always a good time to get out in a novice lab, and I had one opportunity to attend an outreach present an outreach uh, uh, event when I was at Uluru. Okay, so let's talk a little bit about the equipment. So we had a novice presentation back in December, and the topic was night photography and astrophotography setups that people in the club had, and we had various people from HAS come in and talk about their particular set of equipment and showed us some examples of either the night sky or deep sky objects that they captured. One member, Cindy Yepes, she brought in her Dwarf Lab smart telescope. It was a Dwarf 2. And I'd heard about the sea stars as well, and I saw some of the sea stars equipment as well. But the dwarf I kind of latched onto because when I saw her equipment, it looked very compact, and I thought, hey, that would be ideal for a long distance trip like this. So I did a little bit of research after the meeting, and I found that there was this new telescope that Dwarf Labs was making available called the Dwarf Mini. And the Dwarf Mini is what you see pictured here. And what you see here is a pan tilt head on the top of my camera tripod, and everything above that is the Dwarf Mini. A very compact, lightweight telescope that had a really nice field of view for taking images. Uh, Including the carrying case, this thing was about the size of a large shaving kit, and it weighed about 3.5 pounds. And I'll show you this piece of kit on the next slide. The tripod I used was my tripod that I used with my night camera, and it is pictured right here. And I also used this pan tilt head that I got from Dwarf Labs and attached it to my tripod for my camera. This assembly right here was about 14 inches long, 4 inches diameter, and it weighed 3.5 pounds as well. Um, this device, having batteries in it, was something that I would need to carry with me on the plane. So again, weight and compactness was really a key attribute. The tripod, which I could have swore weighed more than the dwarf. There were no electronic parts to that, so I could just stick that in my large suitcase, and I checked that in and didn't have to worry about that. Here is a picture, or a slide rather, with several pictures that shows the Dwarf Mini in packaged into the little bag that I purchased. And so you can see it fits really nicely right in here. I've got some accessories in here like a plug and a cable for charging and for data transfer. So that all fit in here. Here's a kind of a more expanded view of that. And then here is everything all zipped up. And again, like I said, this thing is roughly the size of a large shaving kit. This fit snugly into the bottom of my backpack. You can kind of make out the handle and the little tab right here, the yellow tag, and that's where it fit. Now, I took my night lens and night photography camera with me, just kind of as a backup, and that thing was heavy. And at the end of the day, I only got one picture from it, so it was kind of a waste of weight. But live and learn. And but even with that heavy assembly plus the dwarf, I still had some space in here for other things like a coat or a fleece or other things that I needed to pack with me. Over here, you can see the backpack kind of sitting up on its rear end here, and that's what I used. I was able to put that in the overhead bins or in the seat in front of me on the plane, and it really worked out well. Okay, so that was the equipment. Now I'll talk a little bit about some of the observing locations that I went to. And before I went, I did do some research online to kind of see, where dark sites were available related to my itinerary. And you'll see here, here are the various sites that I went to. So there's a town called Katoomba. And Katoomba is about an hour and a half west of Sydney, and that's where the Blue Mountain National Park is, where I was doing some hiking. Um, Katoomba was far enough away from Sydney that it was shielded from a lot of the light pollution, and then the dark site location that I scouted out was even farther west, so it was even better. So Katoomba was an area I wanted to do some imaging. I went down to Hobart in Tasmania, and the idea, and I was really hopeful that I could do some both observing and imaging down in Tasmania because of its southern location. Um, that was something that I wanted to take advantage of because of the low declination of a couple of objects that I was trying to image. And Tasmania is about 42 degrees south, or Hobart is rather. And so I thought I had a really good shot at getting those before they got down onto the horizon at this time of year. The next area I wanted to do some astronomy work was in Perth, and that was over on the western side of Australia. And Perth and Katoomba are roughly 31, 32 degrees south, so they're as far away from the equator as we are up here. And then the final location that I'd scouted out was Uluru Kata National Park. For those of you my age and older, Uluru used to be known as Ayers Rock. And so that was a very dark location. And not only was I hoping to get, uh, images of these very steep sky objects, but I was also hoping to get some nice Milky Way shots. Okay, so those are the four spots that I went to. Let's kind of dive a little bit deeper into this because, as you'll kind of see here, original plans don't always pan out. So, in Katoomba, I talked to the locals, and they confirmed to me that this Hargraves Lookout was a great location for doing both night sky and astrophotography work. It's a great dark location. However, the day I went up there was after a hike to do just kind of some scoping out. And what I found was it was a bit windy, so that particular night wasn't going to work out. However, as I was making my way up there, I really got uneasy because the drive was fraught. It was remote and it was at night. Uh, I was doing this during the day, but I would have to do this at night. The roads were narrow and winding. There were steep inclines off the shoulder. And then finally, driving on the left-hand side of the road is something that I had to fight 50 years of muscle memory. We drive on the right-hand side of the road here. I've done that since I was 16 years old. And now all of a sudden I'm driving on the left-hand side of the road. And that takes a lot of focus and concentration, even during the best conditions during the day. So I guess bottom line here is I just didn't feel comfortable doing this at night. However, I used an alternative. There was a small parking lot near the hotel I was staying at in Katoomba. It was a concrete parking lot on top of a parking garage. And there were some lights up there. It was a very small lot. There weren't a lot of cars up there. But it did have a nice southward facing horizon. So I had an unobstructed view of the sky. And while it was light polluted, I thought maybe this will work well for the narrowband targets I had on my list. So I gave it a shot, and I thought it did a pretty good job of capturing a couple of narrowband targets. And I'll let you be the judge when we do our sky tour. So that was Katoomba. Next was Hobart down in Tasmania. And again, the locals confirmed my research and said that Mount Wellington was really a great place to do astronomy, astrophotography, so on and so forth. It is a mountain that's about 4,100 feet in elevation. It sits right out, right next to Hobart, the city. So it's up high above the lights of the city, and it looked promising. However, during my visit to Hobart, weather was really an issue. So I really didn't have an opportunity to do anything in Hobart. And you can see this cloud cover up here was typical of what I experienced. Um, Funny story, the first day I was there, I got in the car and was driving up to the top of Mount Wellington, again, just to kind of scope it out. And I had a traffic sign that said road closes at 4:30 due to snow. And I thought, you're kidding. I mean, we just had got into the fall season down in Australia, and I thought this can't be. I got up to the top, it was snowing. So I turned right back down, came down, and waited until conditions improved, but they really never did. So, long and short, as I waited for Perth, which was my next stop on the trip. In Perth, I hit pay dirt. Perth, when you look on a map, Perth looks like it's on the coast of Western Australia, and it's actually farther inland. It sits on the banks of a really wide river called the Swan River. There is a waterfront called Elizabeth Cay, which is where I was staying, and that's where I was able to do five of the seven images that I took. Um, the Swan River, which you can see here in this picture, this big body of water out here, made for a great low south-facing horizon and provided a break from the city lights because you can see some buildings over here, and this river is really, really wide. So it put a little distance between where I was and these buildings. The lighting on the pool deck, which is really what we're looking at here, was low and backlit and downward facing. So the immediate area was conducive to doing um, astrophotography. There were city lights near the hotel, but they were to the north, which would have been kind of where, if you're facing south, it would have been back behind you. And those lights were somewhat blocked by trees and they were relatively subdued. It wasn't the big blinding lights that you see in downtown Houston. It was much more subdued for some reason. And then to make matters really nice, the pool was closed after dusk, so I had the place to myself. I didn't have to worry about water splashing or additional lights or anything like that. So the setup was wonderful. Um, the conditions were great. I had a new moon. I had clear skies for two straight nights, so I could really get after it. And I had somewhat breezy conditions. However, I found this little alcove right here. So you can see that area here in the dotted circle. Zooming in, this is what the alcove looked like. And essentially, what I had was a three-sided cover. I had this brick wall, I had this glass door, and I had this glass wall over here. And I was able to set up my tripod here and stick the Dwarf Mini up above the line here and get into position. I actually got 47 Toucan, which is a globular cluster that we'll look at here in a moment. That's a very southerly object, and I caught it just before it got out of range over here. I was at about 24 degrees above the horizon when I finished imaging. So I pulled it off and I was really excited about that. Bottom line, Perth was the best setup on the trip. So I made hay while I could and did what I could. There were a couple objects I didn't get, but I said, "Hey, you're going to be at Uluru here in a week or two, so let's just hold tight for that." And I'm going to take a quick drink of water, excuse me. And that was my next stop was Uluru Katajuta National Park. And the great thing about Uluru is that there are very dark skies there. I don't know what the Bortle rating was, but you're extremely remote and there really isn't much civilization around there. The neat thing about Uluru is that the horizon was wide open in all directions. Previously, all the locations that I was at had southward facing horizons that I could use to image and to do some observational astronomy, but I didn't have anything in the north until I got to Uluru. So that was really neat. Um, there were knowledgeable, friendly guides that I went out with while I was out there. This is Neil with his laser pointer standing in front of Uluru back here in the background. And Neil and I talked, and I told him who I was and where I was from and what I was doing. And he was very helpful in terms of um, talking about the night sky down there and also providing some images that I was able to use for this presentation. Now, unfortunately, conditions at Uluru were suboptimal. We did have clouds that night, which you can see in these pictures, and we had a full moon, which is really kind of a planning issue that was more my issue than nature's issue. But I had to kind of squeeze this in at the end of the planning for my trip, so I didn't have a whole lot of wiggle room there. But again, if I do this again, that's one thing I'm going to have to pay closer attention to at the phase of the moon. So it was still a great night for observing and learning. I was really able to kind of look at and study the northern sky in a little bit more detail. We saw Jupiter through the telescope that they set up over here. I think it was like a 8 or 9 inch Schmidt-Cassegrain celestron. We saw Alpha Centauri, both A and B, and then we saw a really wonderful view of the Jewel Box star cluster. So it wasn't a total bust. It was a lot of fun and got a lot of questions answered by both Neil and his associate Dave. So that was really a fun time. And I didn't have to drive, and that was probably the best thing about that. Okay, so that kind of sets the stage for what we're about to talk about next. This next section is all about getting the measure of the southern skies. And again, here I want to draw on some of the tools and techniques that we use in our seasonal talks here during the course of the year in the novice meetings. And so we're going to rely on our old friend, the sky maps that you get on skymap.com. And what I've got here is the April 2026 sky map for the Southern Hemisphere. You can read upside down. That's what we got here. And I wanted to start by looking at the north. So in order to do that, I need to turn the map so that north is pointing down towards the ground. And then that will give me the view of the sky that I'll see in the north. And what we see here is familiar, but it's upside down and out of order. So let's kind of zoom in a little bit on that. What am I talking about here? So what I've got highlighted in these little tan ovals are the various constellations that we're familiar with here during the course of the year. So in the wintertime and spring in particular, Orion is becoming less prominent. Of course, in the wintertime, it's a very prominent um, uh, constellation and signpost for us. Taurus is visible as well. Canis Major, Gemini, Leo, and Virgo. But the one thing you'll notice is that these are upside down. So it isn't entirely obvious at the beginning of your viewing into the northern sky what it is you're looking at because you're not used to seeing that pattern of stars in the configuration that it shows up in. And so Orion's belt is here, Betelgeuse is lower right, and Rigel is upper left. Canis Major, the dog, is turned upside down. Pollux and Castor are upside down. Everything's just the Taurus, the bull, the horns are pointing downwards. So it's a little bit disorienting. The other thing, too, is that the position of these constellations seems out of whack. And what I mean by that is I always expect to see Taurus kind of to the right-hand side of Orion, and I expect to see Gemini back behind Orion, and Canis Major being down kind of below Orion. So it just again the orientation that you're at here is a little disconcerting. So, the sky hasn't changed. The key thing here is that we've changed. We're now a whole 60 degrees farther south than where we were before. So, what we used to view facing south is what we're looking at facing north. And because we're facing north, everything's kind of turned around. These things still move in the same direction. In other words, Taurus is still going to go down below the horizon before Orion and Gemini. It's just that it's going the opposite direction, and that's because we're facing north. So, kind of a revelation for me. The sky is familiar, but it's out of whack, it's upside down, and it's out of order. And that's the one thing you kind of have to get your head around. Another thing here too is Ursa Major. So Ursa Major for us is high in the sky. We can use it as a signpost during the spring and the summer, but down there it's almost gone. You can't even see the Big Dipper, at least not the night that we were out there. I did talk to Neil and I said, "Do you guys ever see the Big Dipper?" And he said there are periods of time that they'll see the handle, but that's about it. So that's looking north. That's what's familiar to us. And even though it is familiar name-wise, it's different and something that we've got to kind of get our head wrapped around. Okay, so next we're going to go to that brand new part of the sky, which is the southern part of the sky. So I'm going to turn the sky map so that south is facing downward. And this is what I'm looking at when I'm facing south. And here's what we've got here. Um, we've got some signposts that we can latch onto and utilize. And I'm going to go to this next slide here, which is a little bit more of a blow up of what we were looking at on the last slide. So let's talk a little bit about this. So the pointers are two bright stars. There's Alpha Centauri and Beta Centauri. And actually, Alpha Centauri is a three-star system, and I think Beta Centauri is a double-star system. So it's not one star, but several. But you see one star when you're looking up their naked eye. So Alpha Centauri is made up of a star called Rigel Kentaurus, which actually is Alpha Centauri A and B, so it's a double star. And then there's Proxima Centauri, but it's not part of Rigel Centaur Kentaurus. And Rigel Kentaurus is Arabic, meaning the foot of the centaur, which is the mythical creature that Centaurus is based on. So a centaur is the half man, half horse mythical creature, and Rigel Kentaurus is his foot. Up here is another star or double star system called Beta Centauri, and the star name here is called Hadar. So it's also known as Hadar. And Hadar is Arabic for ground, and uh, it got its name because the astronomers that first documented and observed these stars noticed that these two stars rode very close to the horizon, so that's hence how it got its name. Um, they must have been at a latitude between 30 degrees and the equator to come up with that because from our latitude, you can't see these stars. I'll talk a little bit more about that in a minute. Now they call these the pointers because what they do is they point at another signpost called Crux, or the Southern Cross. And there are two or three different crosses in the southern sky, and it's easy to get on the wrong cross. But if you start with the pointers, they will get you to the proper cross. So this is the Southern Cross, otherwise known as Crux. Crux is a constellation, and it's made up primarily of these four stars that you see here. So here's A Crux. This is uh, Gamma Crucis. This is Mimosa or Beta Crucis, and then this is Delta Crucis. So these are the four main stars of Crux. And again, that is something that we're going to use as a signpost. Um, the Large Magellanic Cloud and the Small Magellanic Cloud are two other signposts that we're going to take advantage of. These are actually dwarf galaxies that are close to the Milky Way. They're not actually part of the Milky Way. And then, of course, these all surround the South Celestial Pole. So the cool thing here is, we learn about signposts to navigate in our quarterly meetings. We have the same tools available to us in the southern sky, which I think is really cool. Okay, here is another picture of the South Celestial Pole. And what I want to do here is put this overlay here. So what I've attempted to do here is show you the boundary that we would experience at 30 degrees north, which is, roughly the latitude of the Houston area. I'm 30 degrees, a little bit over 30 degrees up here in Kingwood. I think once you get closer to downtown, it's probably closer to like 29 and two-thirds, etc. But just generally speaking, this is the boundary. So what I mean by that is everything that is within this circle that you see here we can't see because we're too far north. Okay. However, there are some things that we can see that are really interesting. There's a star that you can see in the dead of winter called Canopus. And Canopus is actually in a southern constellation called Carina. So I've seen this before and kind of used it as my marker to say, hey, I can see this point, which is down in the southern sky. There's also a really prominent globular cluster here called Omega Centauri. And Omega Centauri is a beautiful cluster, and we can see this in our skies here in Houston. The first time I went out to the dark side, I was with Stephen Jones, and he had his big Dobbs telescope and he had it pointed here at this cluster, and it was amazing. And this thing is big, and I think if memory serves me right, it certainly is visible with a pair of binoculars, and I think it's even visible naked eye. But it will only get about 12 to 15 degrees above the horizon. June and July, this will be visible, so I'm hoping to inspire you all to go take a look at this during our summertime. As we move farther out, we can see some familiar constellations. So here we have Canis Major. Over here we have Scorpius. Here's Antares, and then here is Sagittarius and the Teapot. So I just show this to kind of give you a feel for, how far we can reach down and look into the southern sky. And I thought this was, it's an approximation, but I think it's pretty valid. Okay. Here are some pictures that I took with my phone just to kind of give you a feel for the naked eye observing that I was doing. This was in Katoomba, and this actually was I think the clearest night that I had. I did have to contend with a little bit of city pollution, but Katoomba was really kind of a small town, so it wasn't a huge factor. But you can see here the pointers are very prominent, very easy to spot. Crux is very easy to spot, and then I was able to even make out Eta Carinae, which is a large emission nebula that we'll talk more about here in a little bit. The Southern Pleiades is an open star cluster. In all honesty, I did not see that naked eye, but after looking at the pictures when I got home, I could see that object was there in the picture, so I just circled it for posterity. But those are that's a picture of the south-facing sky from Katoomba. Here is the same sky from Perth. You'll notice that the stars are a little bit dimmer, but they're still visible. Eta Carinae is even still visible, but the light pollution from Perth is really kind of washing that out. And then finally, again, the same sky, the view of the sky from Uluru. And I think this picture really points out a couple of um, things that I wanted to mention. Number one, we had clouds and a full moon, and you could still see the pointers and crux. Even a fainter constellation called Musca, you could still make it out. So these objects are very bright. And then also, it's a very dark area, and you can see up here we had a bit of a keyhole, and you can kind of get a sense up here that man, if we'd have had a cloudless night or moonless night, it would have been spectacular. No such luck, but you dance with who brung you. Anyway, just to kind of give you a feel for what the observing looked like, unfortunately, I didn't take any pictures facing north. I can just kind of give you my eyewitness testimony. And again, I would say if you go back to that sky maps view of the northern sky, that pretty much sums it up. I saw Orion, Gemini, and Canis Major, and could distinctly make out them being upside down and out of position. So that is kind of a synopsis or a taste of my observing. Okay, so I'm going to grab a quick drink of water. Thank you. And now we'll embark on our sky tour. And I'm really excited about this. The results that I got, I thought were really neat. So let's dive into this sucker. Here is that same map of the South Celestial Pole region, and I have in green the various objects that we're going to look at. So we're going to look at the running chicken nebula. We're going to then look at the Southern Pleiades. We'll then go on to the Beehive open star cluster, talk about Eta Carinae. We will go look at the Tarantula Nebula, 47 Tucanae, which is a globular star cluster. And then we'll wrap up the images that I took with Omega Centauri. Now, I didn't was unable to get the large and small Magellanic Clouds or the Milky Way on my own. However, again, the good people from Uluru Astro Tours helped me out, and we're going to use some of their material. So let's pretend it's getting dusk out there. We've got this. The dusk is drawing near on Uluru out in the middle of the center of Australia, and now let's get into it. So let's go to our first object, which is the Running Chicken Nebula. And here it is, the Running Chicken Nebula. So, and before I get into that, let me go back up here quickly. In order to find the Running Chicken Nebula, we have to go 10 degrees from the center of Crux in order to find that. This nebula is in the constellation of Centaurus. So kind of there's a little peninsula that kind of swings out here, and that's where we'll find the Running Chicken Nebula. And the Running Chicken Nebula is about 5,900 light years away and is about 110 light years in size. Okay, so I've studied and tried to understand where the chicken is, and the best I can ascertain is this is the body of the chicken right here. And this is the head of the chicken, and he's kind of running at us. Now, I've seen other depictions that kind of show additional parts, but what I was able to capture kind of shows you the running chicken nebula. So this nebula surrounds the open star cluster called Lambda Centauri, and that star cluster contains these stars here, as well as this large star called Lambda Centauri. And Lambda Centauri is a third magnitude star. It's a blue-white giant, and it's a great marker if you are going to go out and try to view this thing naked eye because it's so big and it's so bright. Um, a couple of features about the running chicken nebula. There is a small dark patch here, and that is called a Bok globule. And what that is, it's a small dark nebula that contains dense gas and dust. And this is where star formation is conducive, right in these little formations right here. Now, if you zoom in on this, you can see a lot more of an archipelago of these Bok globules. But that is the Bok globule I was able to pick up with the Dwarf Mini. So again, you've got Lambda Centauri, third magnitude star, and this star cluster, and then the surrounding nebulosity. And that is the Running Chicken Nebula. Let's move on to our next object, which is the Southern Pleiades. Now, the Southern Pleiades is located right here. And it is an open star cluster in the constellation of Carina. So it is back over into this constellation here. And Carina is where you'll find Canopus rather. We can see Canopus here in at 30 degrees north, but the rest of this is too far south for us to make out. Okay, so here is the Southern Pleiades. Um, it is about 530 light years away from Earth, and it has a size of about 15 light years. It's also known as Theta Carina, and that would be, and it's named after this bright star that's in the center of the cluster right here. This is Theta Carina, the star. This star cluster does have kind of that bluish glow that we see with our own Pleiades here in the northern hemisphere. However, it doesn't have the reflection nebula that we have with the with the Pleiades that we're familiar with. But it is a rather beautiful open cluster. It has about 60 stars in it. Um, this star cluster is the third brightest open star cluster behind Hyades and the Pleiades. And it's a very wide field of view object. It spans about 50 degrees. So a full moon is 30 degrees. So about two full moons will give you the approximate size of this up in the night sky. This bright star Theta Carina is actually part of one of those crosses that I was talking about called the Diamond Cross. And I'm going to just hop back up here real quick. So here's the open star cluster, but Theta Carina is the big bright one in the middle. And along with these three stars here, it makes up that Diamond Cross. So I thought that was kind of neat. Um, this star cluster was first discovered by a French astronomer, Abbot Nicolas Louis de La Salle, on March 3rd of 1751, down in Cape Good Hope in South Africa. Probably didn't pronounce his name exactly right, but that's when it was first discovered, and that's the Southern Pleiades. Next, we're going to move on to one of my favorites out of the images that I took here, and that is the Southern Beehive. And that is about 15 degrees from the Large Magellanic Cloud. So if we find the Large Magellanic Cloud and go up 15 degrees, we can find the Southern Beehive. This open star cluster is also in the constellation of Carina, and it is about 1,300 light years away and 12 light years in size. It contains about 100 stars, and the brightest one is this fifth magnitude red giant right here in the center. The cluster is about 70 million years old, so in galactic terms or cosmic terms, it's not very old at all. Um, you'll notice that these three prominent red stars up here are very beautiful, but they are not in the cluster. They're foreground stars. However, they're really handy stars to have next to this cluster because you can easily find these when you're going and looking out for something for this star cluster with a pair of binoculars or naked eye. You can find this bonnet or this halo of these red stars, and boom, you're right there at the Southern Beehive. So anyway, this is a beautiful star cluster, and again, it got its name Southern Beehive because it has some resemblance to the beehive that we're familiar with up here. Next, we're going to go to Eta Carinae, which has really got a fascinating story. And Eta Carinae is in the constellation of Carina. It's about 12 degrees from the center of Crux. And I'm going to show you the picture here. I wasn't able to actually capture the entire nebula. Um, the Dwarf Mini has a mosaic function, but to make a long story short, I wasn't able to make that work for me the night I was doing this. So there are pieces of these fantails up here, here, and down here that got cut off. But I captured most of the nebula. So this isn't a mission nebula. No, the real mind blower about this one here, um, this this uh, this particular nebula is 10,000 light years away. So it's almost at kind of the same scale that you would see a globular cluster in terms of distance. And its size is really massive. It's about 350 light years in size. So just to kind of put that into context, M42 is about 1,300 light years away and about 35 light years in size. So this thing is roughly an order of magnitude in size and distance than our own M42. Now, this is a large, bright nebula that contains several open star clusters. So there's a star cluster down here called Trumpler 16. There's another star cluster up here called Trumpler 14, and then there's other star clusters scattered throughout the nebula that you can see over here. There's a really famous kind of a dark patch called the Keyhole Nebula, and that's this little pattern that you see right here, this little object that you see right here. And that is really cool. This region is one of the largest H2 regions in the Milky Way. So this area of activity is huge. And the main star, or pardon the pun, is the star called Eta Carinae. Now, this is a variable star. It's a large blue variable star and has a really interesting history behind it. So, when it was first discovered, it had a magnitude of about 4. And then in 1827, there was a naturalist, William Burchell, who noted Eta Carinae's brightness increased to a 1 magnitude. John Herschel, who we're going to hear more about in tomorrow's general presentation, was in South Africa during the 1830s, and he made a series of detailed measurements concerning Eta Carinae. And he noticed that in 1837, December 16th to be exact, the magnitude or the brightness of Eta Carinae increased to approximately plus 0.28, which would be roughly the brightness of Rigel. So it got extremely bright. And this marked the beginning of a period of time called the Great Eruption. And what was happening during the Great Eruption is that material was being ejected off of this star. I think the theory is because of its size, it's a massive star. This ejection was a means or a mechanism by which it could regain some stability. Okay. Now, this next slide shows you a nebula that resulted from that ejected material, and this is called Homunculus. And you can see here the star is in the middle, kind of glowing, and it's shrouded by all this gas and dust that you see here. And just for reference, it would be approximately here in the picture that we just looked at. Now you'll notice here, this is a model. There's a hole right here, and this is probably wishful thinking on my part, but I wonder if that's maybe that hole. I don't know, it probably isn't, but it's always nice to wonder. Any event, this is a nebula that's shrouded Eta Carinae, and it is a result of this great eruption. And that great eruption lasted about 18 years. So from 1837 to 1855, I guess, is the period of time that the eruption lasted. So very interesting history. John Herschel, who was the son of William Herschel, uh, very renowned astronomer, was deeply involved in this discovery. And so that is the star, and the nebula Eta Carinae. Okay, next we're going to go on to another really mind-blowing object called the Tarantula Nebula. Now, the Tarantula Nebula is down here, and it actually resides in the Large Magellanic Cloud. It is in the constellation of Dorado, which you see down here. And this object is an emission nebula that is 160,000 light years away from Earth and has a size of about 1,800 light years. So it's massive. And this is the picture that I captured of the Tarantula Nebula, which is really this main piece that you see down here. Now, this is the largest and brightest nebula in the Large Magellanic Cloud, and it also is one of the largest H2 regions in the local group. So the local group, it consists of the Milky Way, the Large and Small Magellanic Clouds, Andromeda, Triangulum, and a myriad of other galaxies as well. So this is a massive emission nebula. This nebula lies at the leading edge of the Large Magellanic Cloud, and you really can't make that out from this image. I'll show you one here down the road that kind of shows you a little bit more about where it resides in the Large Magellanic Cloud. But it's on that leading edge of the galaxy, and it's thought that the movement of the LMC and the weight or the resistance that we get from the interstellar medium is actually compressing this nebula and is creating a really rapid rate of star formation as a result of that. Now, this is another mind-blowing facet or fact about the Tarantula Nebula. And again, I'll use M42 as a way to kind of put it into context. M42 has a 2 to 3,000 solar masses in it. The Tarantula Nebula has anywhere from 450 to 500,000 solar masses. So it is unbelievably huge. And it would have to be in order for us to get an image like this of an object that is 160,000 light years away. So this is really, again, just kind of a really neat story, a really neat object. There's a star cluster here at the middle called R136, and it contains all these solar masses, and it's those solar masses that are producing all the radiation, all the energy that's making this thing glow so bright that we can actually image it. This nebula also serves as a great laboratory for studying the formation of large and massive stars. So again, it's another one of these objects like Eta Carinae. It just has not only is it beautiful and different from what we've seen, but it has a really unique and interesting story behind it. So that's the Tarantula Nebula. Okay, so next on our journey is a globular cluster down here around the Small Magellanic Cloud called 47 Tucanae, and it is in the constellation of Tucana down here. And this cluster, which I'll show you right here, is about 15,000 light years away and is 214 light years in size. So when I first saw this object, when I was putting my list together, I thought, how did it get its name 47? I mean, what happened to 1 through 46? Well, 47 Tucanae got its name because it was historically cataloged as the 47th star in the constellation of Tucana. So that's how it got its name. Apparently, at the time it was cataloged, the you couldn't resolve this. The people that were involved were unable to resolve the stars. So that's how it got its name. Now, this is the second largest and brightest globular cluster in our night sky, and it contains about a 500,000 to 1,000,000 stars. And so it is really pretty. I think it's beautiful. And just a little shout out to the Dwarf Mini. I got, it's a wideband target, but I was actually able to get some pretty good resolution. I mean, it gets a little bit blown out here in the center, but considering that I was imaging this in a city and low on the horizon, I was very satisfied with being able to get this image. This object lies about minus 72 degrees declination, so it is extremely southerly. And during the time of year I was there, it was getting near the horizon early in the evening. So that's 47 Toucan A. Now, as I was looking at this when I got home, I noticed a couple of things here and here, and I thought, well, what the heck is that? I'll bet that's something other than a star. So after a little research, I think what I've got here pictured was a galaxy called PGC, and that is 260239. And that galaxy is about uh, 500 million light years away. And PGC stands for Principal Galaxy Catalog, but 500 million light years away. Unbelievable. And then down here, I believe, and again, this is basis my research on Sky Safari, I picked up a globular cluster called NGC 121. And that cluster is actually part of the Small Magellanic Cloud, and it's about 200,000 light years away. So, again, shout out to the Dwarf Mini for picking up these items. Again, I researched it as closely as I could. I think I'm on solid ground here, but that's what I think I picked up. But anyway, 47 Toucan A, just a wonderful, brilliant object. Okay, next we're going to look at Omega Centauri. And that's a globular cluster up here. And the one thing before I show you the picture is I really want to encourage people to get out to the dark side this summer and look at this for yourself because it is an object we can see and it's a wonder to behold. This object is 14 degrees from Hadar. So we find the pointer Hadar, we go up here. Now, when you're out at the dark side, you actually would just look due south and wait for that big glowing orb to come up over the trees. And that's really kind of the best way to capture it. There are other markers out there that you can use, but that's how I remember it the night I saw it with Stephen. It is in the constellation of Centaurus, and here is the image I was able to get with the Dwarf Mini. This object is 17,000 light years away. It's 271 light years in size. It got its name kind of in the same way that 47 Toucan A did. It was mistook for a star. Ptolemy, in particular, mistook Omega, this as a star, hence the name Omega Centauri. This cluster is estimated to have around 10 million stars. It's huge. It's the largest and most luminous globular cluster in the Milky Way. And of all the globular clusters in the local group, it's only second to a cluster called Myal 2 in Andromeda. So this is a really wonderful, beautiful object. It's thought to be the remnant core of a dwarf galaxy that perhaps is harboring a black hole. However, those findings haven't been confirmed. Nevertheless, again, I think the dwarf did a wonderful job, and I'm giving credit to the dwarf and not me because literally this device is something you stick in the ground, turn on, and it kind of does its thing. So again, really, really pleased with the result here. I didn't quite get the redness of these stars that you can see in some of the more um, elegant or detailed images, but again, I was thrilled to get this. And so that's Omega Centauri. Okay, next we're going to go look at the large and small Magellanic Clouds, which also serve as our one of our signposts. And here is a picture that I got from Neil at Uluru Astro Tours. This was taken back in January of this year. And here you can see the large and small clouds. Now, I'm going to show you some close-up pictures. Here's the large Magellanic Cloud. These are a bit fuzzy and grainy. This is in no fault due to the photographer's work. This is what he had taken a picture of, and being able to get this cropped in image as clear as I did was testament to his work. So let's talk a little bit about the Large Magellanic Cloud. It is in the constellation of Dorado. It is 160,000 light years from Earth, and it's about 29,000, 30,000 light years in size. So it's roughly a third the size of our own Milky Way. It does have a bar structure here, and it's got some faint spiral arms here, but this bar and these spiral arms are thought to have been deformed and deteriorated due to the tidal interaction between this cloud and the Milky Way. So it is probably was a more fully defined galaxy, but due to the interaction with the Milky Way has been kind of torn apart to a certain extent. Here you can see our good friend the Tarantula Nebula right here. And you can kind of see it's on this leading edge out here of the galaxy. And you can kind of you kind of wrap your head around the fact that as this galaxy is moving, you're going to get some compression effects from the interstellar medium, which would explain the high rate of star formation in the Tarantula Nebula. Um, it is very rich in gas and dust. That is the Large Magellanic Cloud, and is experiencing some rigorous star formation. In about 2.5 billion years, this galaxy is predicted to collide with our own Milky Way. So um, it has a destiny similar in nature to what Andromeda will have with us, only sooner. So that is the Large Magellanic Cloud. The next is the Small Magellanic Cloud. It's a sister galaxy out here. This is in the constellation of Tucana, just like 47 Tucanae. It's 200,000 light years away, and it's about 18,000 light years in size. So it's roughly a fifth of the size of our own Milky Way. It is classified as a dwarf irregular galaxy. And you can kind of make out a bar formation right here. Um, Even though it's has a very low declination, if you're at 15 degrees north or south of that point, you can still catch a glimpse of this. So it is something that can be seen from the northern hemisphere, but you got to be down somewhere in the vicinity of probably Honduras or Nicaragua. Um, it has a very low surface brightness, so a good dark location, moonless night is a preferred set of circumstances to see this. Again, in all honesty here, I was unable to see these two galaxies naked eye. And primarily because I was relying on Uluru and I had to contend with that full moon and the clouds. So I was unable to spot this, but on a clear, cloudless night, you should be able to find it. You'll notice also down here, our good friend 47 Tucanae. So you can kind of make out some of the stars emanating from the center of that globular cluster. So that's the Small Magellanic Cloud. Next, and we're getting near the end here, is the Milky Way. And I kind of turned the picture in a different orientation to kind of match up what you see here on the screen. Um, Again, this was taken back in January by either Neil or Dave at Uluru Astro Tours. And it's a marvelous picture. The one thing I wanted to mention about this one, in last month's meeting, we were talking about the Milky Way, and we had a discussion about how the summertime is really an ideal time to look at and image the Milky Way because you're looking back towards the center of the galaxy. And then during the wintertime, as you look at the galactic disk, it's really faint and not very spectacular. Well, here it is actually pretty spectacular and a very beautiful shot. And the reason I think is because these are all the images that we've actually looked at in our sky tour. You have a series of really bright objects out there, and there's many more than what I've got listed. But you have a series of bright objects that are probably enhancing that view and giving us a really pretty view of the Milky Way, bright view of the Milky Way, even during the winter time. Okay, now I did get a consolation prize. I did mention that it wasn't a total full moon, but it was pretty close. The night we were out there, we had what was called a lunar halo. And now I know what you're thinking. This thing probably is some kind of a defect with my camera lens, but I can, again, with eyewitness testimony, tell you that this was visible in the night sky. Our instructor Neil even gave us a little bit of background on the lunar halo. It is a real thing, and this happens when moonlight refracts through millions of tiny hexagonal ice crystals suspended in high altitude clouds like cirrus clouds. And then what these crystals act like is miniature prisms, and they'll actually spread the light out, bend it away, and it gives you an exact 22-degree circle that you see here in the picture. And again, Neil told us this. I came home, researched it, and lo and behold, that was what I found as well. It is an atmospheric condition, so it is something that we can see up here in the northern hemisphere as well. But I just wanted to show you that because it was really kind of unique and quite beautiful. Okay, so we've ended our tour. We now have the sun rising in and around Uluru. I'll share a quick story with you. We were going out to this observation point. We are hiking up this trail the morning I took this shot, and I caught out of the corner of my eye the silhouette of Uluru as the light was beginning to show, and I was stopped in my tracks. It was unbelievable. Anyway, I thought it was a nice picture to include in here to kind of bookmark our sky tour. I've got a couple of tables here. I won't go into too much detail. If anybody has any, questions or wants to get a copy of this table and the next one, I'm more than happy to share that with you. The one thing I will point, a couple of things I'll point out. Here we have, look at this magnitude of these objects we looked at. They're very bright, which is just amazing. And then the altitude above the horizon, again, I talked about 47 Tucanae being so low, but look at Omega Centauri. Again, we will see it at maybe 12, 13, 14 degrees above the horizon. In the night I imaged this thing, it was 44 degrees and going up. So I thought that was pretty neat. So just some really beautiful objects. And then here is just some imaging information. Um, One thing that I will point out is the Dwarf Mini images I processed in the Dwarf Lab Stellar Studio and Lightroom. Um, and I used alt azimuth tracking. So I made it simple. I took about 30 minutes worth of 15-second exposures on each of these. And again, I thought they turned out really good for a presentation like this. Okay, final thoughts, objectives. Think through what you want to accomplish. If you're going to go down to the southern equator, or even if you're just going to go out to West Texas, or you're going to go somewhere, unique or long distance wise, think through what you want to accomplish on an astronomy expedition. Do I want to do observation? What kind of equipment should I take, etc.? Equipment, take what you can handle and what you can manage. Um, for me, the Dwarf Mini worked out wonderfully. I know that Seastar and probably Dwarf Labs are going to continue to make their devices smaller and more powerful. So that's something that's kind of on our side here and something to take a look at and take advantage of. If you're going to do just visual, pair of binoculars is always a nice choice. But again, think about what you want to take and how you want to manage that. Locations, spread your bets. Multiple locations if you can, multiple nights if you can, just to take advantage or to mitigate, any kind of issues you're going to have with weather. And be flexible. So you saw where I had some locations that didn't work out for me. I tried something different and was able to get what I thought were very satisfactory results. The southern sky, just some thoughts about that. It's familiar but disguised. So the northern sky was familiar but disguised. Orion and Gemini and Canis Major, they're there, but they're in a position that we wouldn't recognize them right off the bat. We have new signposts, and we can use signposts down there. So the pointers, crux, the large and small Magellanic Clouds are available for us to use. The new constellations that we learned about were really neat. So Centaurus, Crux, Carina, Dorada, and Tucana. And if you go out and if you look for Canopus during the winter, and if you go out and look for Omega Centauri during the summer, you can add a couple of constellations to your list. And then deep sky objects. They are big, bright, distant, and they are amazing. So, with that, I thank you, and I will stop sharing. And Steve, I'll turn the floor over to you.
Very good stuff. Very good stuff there. Uh, any questions? Nobody's posed a question yet or anything? I'll make a comment that on one of my trips to the Southern Hemisphere with other astronomers, and one night we were just standing there looking up. I think, what the hell is that constellation? We just could not figure it out. What we had to do is we had to turn around backwards and look up. Oh, it was Leo. It's
Hmm.
just the way things are reversed um, from down here.
Exactly. Yeah, and that was
So,
what I was trying to get across is that you just don't recognize it right off the bat. So,
yeah, and you see Scorpius rising with his tail first, and then
right.
his head.
Yeah,
So,
it's crazy.
yeah,
So no, nothing in the chat. Well, if there
Yeah,
isn't anything in the chat, people can just come off of mute
I,
and ask their questions if they want.
I was just going to say I found it very amazing to simultaneously see Antares and Betelgeuse above the horizon at the same time, so I could look back and forth and compare them.
Yes.
And seeing the center of the galaxy dead overhead.
No, I didn't see that, but because I wasn't there at that time of year. But yes, that is.
And I had to go inside because it got so cold. So I'm looking at Sagittarius dead overhead, and I finally have to go back in the hotel room because it's so cold. Because
And now,
it was like 20 degrees
now, where were you at, Phil?
outside Melbourne.
Okay.
And what was the name of it? There's an interesting park, like a few hours drive west of Melbourne, and I was there with friends. And then there's a hotel in the middle of nowhere, and so I just walked like out away from the hotel into the darkness. And yeah, I had to give up because it was like 20 degrees and I was freezing cold. And but just seeing the Sagittarius dead overhead, and I can say the Magellanic Clouds, if you have a dark sky, are easy, easy,
Hmm.
easy, easy. No, they're obvious, and
Hmm.
it looks like seeing a deep sky object at one power. You know,
Hmm.
it's like you would be looking at a big telescope at like a galaxy or something, and it's really bright, and except that you're seeing it with your just naked eye. That
Gotcha.
was it was interesting. Yeah, that's they have a lot of bright stars and bright things. And I got to see I visited the Melbourne's Astronomy Club let me go to their dark sky site, and they showed me that blue colored planetary nebula, which was just amazing. It's just like the bluest planetary nebula.
Okay.
we had
Awesome.
a we
Yes.
had a comment in the chat. Chris, do you want to come on off mute and say what you typed in here?
Yes, I was able to capture them. I was stayed for 3 days in Joshua Tree National Park, May 14th, 15th, 16th, and there was a star party. And one of the astronomers said you can capture the month of May and June from California. I went back to my Airbnb, used a Dwarf Mini. I caught it.
And what did you catch?
It
Where
was
were you?
Omega Centauri.
Oh, okay. And where were you at?
Joshua Tree National Park, Southeast California.
Oh, okay. Excellent.
And
Beautiful.
talking about southern constellations, I'll be in Atacama Desert in December. So hopefully I can replicate what you did, including Magellanic Clouds.
Yes. Yeah. Atacama is a really wonderful place as I understand it. So, yeah, I wish you luck. And if you got any questions, reach out.
Sure, thank you, sir.
You bet.
On one of our other trips to South America to see Halley's Comet, one night we stepped out of the bus and sitting there right in the sky with the two Magellanic clouds. I mean, just
Mhm.
there in your face. It's just really great to see that.
Oh, I was also just going to say I have seen and photographed the top three stars in Crux from Brazos Bend State Park. However,
Really?
they're in the grass.
Okay.
However, I got in an argument with Barbara Wilson, the director of the observatory, who said you couldn't see that, and I said no, you can. They're just like really, really low, but you can just barely see it. And so I took a picture and proved it to her. And yeah, I shouldn't have done that. Actually, it got her mad. But uh, but anyway, you can actually see the top three stars just barely.
Yeah.
But you have to go from near the front of the park and get a place with no trees, just grass.
Okay. All right. So we're running a little late. So are there any other questions that anybody has? And if you've got a question, you can just come off of mute. And I'm going to do my auctioneer imitation. So going once, going twice. All right.